Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. Even though it's made up, it's most likely an exam question or a midterm question if it is written out. It can be an assignment question if they allow you to use software or coding. So we have a rigid tank with a volume of 15 liters, 11 kilograms of refrigerant -134A, initial pressure of 300 kPa, and heat is added until it reaches 600 kPa. Find the new temperature and total enthalpy. What they should have wrote is just find the temperature. It's a little bit misworded, I believe. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. Rigid tank, refrigerant, initial pressure, mass, volume. Step 2, list all the given variables, find the unknown. So we want to find temperature and total enthalpy. Note that it's not specific enthalpy because it's capital H. Okay, to find the temperature, we got to go to the pressure table at 300 kPa. We also need to know the specific volume to find the state. We are given the rigid container information, so that means the volume stays the same for final and initial. So first, step 4, we're going to convert our liters to meters cubed by dividing by 1,000. And the specific volume formula is little v is equal to capital V divided by m. So that's your actual volume divided by mass. We'll get 0.00136 meters cubed per kilogram. Step 5, go to the pressure table, find 300 kPa. It's in between 320 and 280. So that means we need to linear interpolate. Next, we're going to check our specific volume. So it is in between saturated liquid and vapor. That means it is saturated mixture. That means we can find our temperature at the saturated temperature table or column. However, we still need to linear interpolate because it's in between. Step 6, find the general formula to linear interpolate. So we're going to use the ratio method. So here it is. Step 7. So the left hand side is the pressure. The right hand side is the temperature. And once we linear interpolate, the temperature at 300 kPa is 0.61 degrees Celsius, rounded up to 2 decimal places. Originally it is 0.605 degrees Celsius. Moving on to part B, step 8, find a total enthalpy formula. So the total enthalpy is equal to the initial plus the final enthalpy. Step 9, find the initial enthalpy formula. So it's mass multiplied by the specific enthalpy. We're given mass, we need to find the initial specific enthalpy. So step 10, find the formula for initial specific enthalpy. Little h is equal to hf plus x multiplied by hfg, x being quality, and that's the initial quality. And the specific enthalpy for the saturated liquid and the enthalpy of evaporation can be found in property tables, so we'll find that after. We'll first find the quality. Step 11, find the initial quality formula. So x is equal to V minus Vf divided by Vfg. So we found our initial specific volume already. So we need to find the specific volume for saturated liquid, and we need to find the evaporation specific volume. Okay, so let's find Vf. So step 12, we're going to find Vf. So we're going to go to our table. So we're going to linear interpolate because once again it's at 300 kPa. So our Vf will be 0.0007734, and that's meters cubed per kilogram. Always list your units. Your professor is not as lenient as I am, and they will mark you down for that. So always make sure you fill in your units. Okay, so step 13, find the specific volume of vaporization or evaporization. So VFG is equal to VG minus VF. So that means we need to find VG because we just found VF. So step 14, we're going to find the specific saturated vapor volume, so VG. Once again, we linear interpolate, and as you can see, we've done 3 linear interpolations. So in an exam, this is very time consuming. So you probably would have just spent like 15-20 minutes just linear interpolating. Okay, and most exams are like 3 hours. So once you've done your linear interpolation, it's 0.0680579. Once again, do not forget your units. Okay, and that's meters cubed per kilogram. So step 15, we can now find the initial quality. So just to recap, we've got our initial specific volume in step 5. So we're just going to backtrack just a little bit. I know students tend to forget things. So this is how we got our initial specific volume. In fact, it's probably step 4. Apologies. Okay. So step 4. And step 12 is the VF right over here. So just in case students are lost or confused where we got these values, that's the step that it is calculated. And step 14 was just our previous one right here. Okay, so we're going to plug and play. And the units cancel out, so it's unitless. It becomes 0.010798. Alright, so next we need to find the saturated liquid enthalpy, HF. So that's HF. And once again, we need to linear interpolate. So for students that are watching this, you can view the pinned comment. It's got the Python code to linear interpolate, so you don't have to spend 1 hour doing this question. Alright. So your HF at 300 kPa is 52.65 kilojoules per kilogram. Step 18, we're going to find the HFG. So once again, 300 kPa, so we need to linear interpolate. I'm sure you'll be a master at linear interpolation after this question. Alternatively, you could have just used your software to do it for you. So you get 198.195 kilojoules per kilogram. Alright, step 19. We can now find the initial specific enthalpy. So that's little h initial. So these are just the steps where we got the values. So HFG, that's just the previous one. Step 16, previous one to that. And then 15 is the quality. So all of those are nicely placed together. Okay, plug and play. your specific initial enthalpy is 54.7901 kilojoules per kilogram. Step 20, find the initial enthalpy, and that is with a capital H. So it's mass multiplied by the specific initial enthalpy. So 11 kilograms multiplied by 54.7901 kilojoules per kilogram. And that gives us 602.6911 kilojoules. The kilograms cancel out. Step 21, find the final enthalpy formula. Same as the initial, but with the final. Okay, so that's mass multiplied by the specific final enthalpy. Step 22, find the final specific enthalpy formula. It's the same as the initial, but with final values, of course. So little h final is equal to HF plus quality final multiplied by HFG. So that's enthalpy of evaporation, and both HF and HFG is at 600 kPa. So step 23, find the final quality formula, same as the initial. And the initial specific volume is equal to the final specific volume because of a rigid container. So we worked that one out already. So we need to find VF and VFG at 600 kPa. Okay, so step 24, find the saturated liquid and vapor specific volumes. So we go to our 600 kPa pressure table, and it will look something like this. So those are the values. No need to linear interpolate, luckily. So they happen to have a 600 kPa in the property table. Step 25, plug and play for the final quality. So we get 0.297721, and it's unitless. Step 26, find the final specific saturated liquid vapor evaporation enthalpy. So that will be HF, and that's HG. The middle one is HFG. Okay, so those are the values. Step 27, we're going to find the final specific enthalpy, so we're just going to plug and play the values. So the quality for the final is step 25, and the rest is given in 26. Okay, so your final specific enthalpy is 135.2386 kilojoules per kilogram. Step 28, find the final enthalpy. So that's the capital H final is equal to mass multiplied by the final specific enthalpy. So that's 11 kilograms multiplied by 135.2386 kilojoules per kilogram. Once again, the mass units cancel out, so you're left with 1487.6246 kilojoules for your final enthalpy. Step 29, we can now find the total enthalpy, so we just add them up together, and these were the values that we got previously. So we get 2090.3157 kilojoules, And that is the answer for part B. Disclaimers. The method is correct, however I do make calculation mistakes, especially with linear interpolation. I highly encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video onto your PC, just in case this video or channel gets taken down while I follow all copyright laws. Sometimes things happen. If you're on a Mac, use the Mac equivalent of Snipping Tool. If you never used Snipping Tool before, follow these instructions. Click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in Snipping Tool, open up the program. Click on Video option, click on New. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in Snipping Tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square in Snipping Tool to stop recording and then save your video. Thanks for watching, hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.